Alright guys, welcome back. And before we actually start looking at an actual example of how to sketch a quadratic graph, I just want to prove to you that the completed square form is exactly the same as the general form of the quadratic. It's just written a different way, alright? But this is going to be the same as that. I'm going to prove it to you now. Now, I'm going to prove this is the same as this using this quadratic expression, and of course you guys know by now that 1 comes there, right? Now based on this, it simply means that the value of A is 1, the value of B is positive 3, and the value of C is positive 2. We can all see that now. Now we know based on this that the value of A is 1. So I have this here. So the value of A is 1, and the value of H is B over 2A. And this simply means H is equal to B, which is 3 over 2 times 1, which is just 3 over 2. So we have A, and now we have H. So the only thing left for us to find now is K. And again, the formula for K is 4AC minus B squared over 4A. So let's plug in the values now. So this would be 4, A is 1, C is 2, and B is 3. So that would be 3 squared over 4 times 1. So I'm just going to get that worked out. So K would be equal to 4 times 1 is 4 times 2 is 8. And this is 3 squared is 9 over 4. So K would be equal to 8 minus 9 is negative 1 over 4. So K essentially is equal to negative a quarter. So I have A, which is 1, H, which is 3 over 2, and K, which is negative a quarter. So what I'm going to do, I'm going to plug in those 3 values inside here, and I'm going to show you by expansion that this is going to give me back this, which is 1x squared, essentially is 1x squared, plus 3x plus 2. So I'm now going to plug in the values now. A here would be 1, so it's x plus h, that's 3 over 2 all squared, and k is minus a quarter. So I'm going to show you now that this completed square form is exactly the same here. You'd appreciate it more if I do this when we get back to the graph work, that the completed square form is in fact equal to the general form of the quadratic, which in this case we have the specific form now. So I'm going to slide this over here for reference and continue working to show you. Now what I'm going to do essentially is to write the completed square form, which in essence is this. Okay. Now, what I'm going to do now is expand. Now, this here is the same as 1, and this is squared, so this times itself. So it's going to be x plus 3 over 2 times x plus 3 over 2. And then I'm going to close this. So this all squared is this, and then put the minus 4 outside. So I'm going to expand what's in the bracket. So x times x is x squared. X times positive 3 over 2 is positive 3 over 2x. Positive 3 over 2 times x is positive 3 over 2x. And 3 over 2 times 3 over 2 is positive 9 over 4. And then I'm going to put back the minus a quarter there. So again, I'm showing you that the completed square form is in fact 1x squared plus 3x plus 2. I'm going to show you. So what we have here is 1. That's x squared, and 3 over 2x plus 3 over 2x, the denominators are the same. So what you're going to get here is 6x over 2 because the denominators are the same. And then we have plus 9 over 4 minus a quarter. So what we're going to do is multiply everything inside the bracket by the 1, and what you're going to end up with is 1 times x squared is x squared. 1 times 6x over 2 is still 6x over 2, and 1 times 9 over 4 is 9 over 4. And now I've expanded using the 1, so I can just, I've now gotten rid of the bracket, so I'm going to write the quarter there. So, just proceeding from here, remember again, I'm showing you that this here is exactly the same as 1x squared plus 3x plus 2. So, I'm going to need to move this out of the way and then continue working with another sheet right here. So we're almost finished now. So the x squared is there. Obviously 2 can go into 6 3 times. So that is 3x plus 9 over 4 minus a quarter. So it's x squared plus 3x, and the denominators are the same. So we just deal with the numerators. So it's 9 minus 1 all over 4. That's x squared plus 3x plus 8 over 4. And you can clearly see that we're going to get back the original quadratic. All right? So what am I proving here? That the completed square form is the same. It's the same. It's just written a different way, and it's written a different way because of the significance this form has with regards to the graph, right? So the completed square form is exactly the same as this. It's just written a different way for a reason, and that reason is to show you the connection with A, to indicate if it's positive or negative. It tells us whether it's the curve, the parabola is a smile or a frown. H, the negative of that, x equals the negative of that, is going to give us the equation of the line of symmetry. And K is going to be minimum or maximum dependent on whether or not A is positive. If A is positive, that's a smile, so K would be a minimum. And if A is negative, then you would have a frown, and then K would be a maximum. So the significance of the completed square form, why we need to learn this, is because we can look at it and tell a lot about the graph. So I hope you guys appreciated this working out. When we come back, we're going to look at our first example of how to sketch a quadratic graph.